And we're back with another episode of Unplugged. I'm your host, Jacob Puckett, and this week, or this month, I should say, we are here with Mike High, our Director of Engineering. And Mike is going to talk to us about a whole bunch of things today. We're going to talk about the elephant in the room with Texas and kind of what's went on there with the extreme cold and the polar vortex. And we're also going to talk about locally some projects we're working on here for transmission and reliability and how we're making tomorrow's electric grid happen. I just know there's a lot of interest about Texas, what happened there, especially with that cold spell, the rolling blackouts, and I guess the science behind that and kind of what goes into it. So, Mike, do you want to dive in and just kind of explain the Texas situation from an engineering standpoint?
There's a lot of details that'll probably come out later, but from what we know now, I think some of it just came from the initial design. In that area of the country, they were not prepared for this kind of weather. Typically in the Texas area, that they didn't design for the ice and the extreme cold temperatures they did experience. So when they did experience those conditions, they had extreme problems with their infrastructure. I think they had a power supply issue as well. They had, from I understand, they had some issues with their natural gas, getting natural gas to the power plants, as well as some of their wind turbines actually freezing up. So I think some of it was from the design perspective, and I think some of it was from a power supply issue.
And talking about the power supply issue, I think we've heard a lot in the news the last couple of weeks, really, about that. Texas is kind of unique in a certain way. They're not like a lot of people will ask, you see on news articles, well, can this happen in North Carolina? And I guess to a degree it could, maybe it couldn't, but we do have the ability to tap into energy from other states, right?
That's correct. I think Texas is the one state who is kind of a standalone type thing. In North Carolina, we have ties to Tennessee, to South Carolina, Georgia, to Virginia. So there are ties to other states where we can pull power resources from. This condition could potentially happen under extreme events. It would be more localized than it would be as widespread as it is in the state of Texas.
And the rolling blackouts thing, I think that's really interesting because when I think of rolling blackouts, obviously a lot of times I think of summer. When you hear about blackouts, you think about hot weather. I don't know why that is, but it just seems like they're more common under those conditions. I guess it just seems like extreme heat's more common these days than extreme cold. So what's the idea behind the rolling blackouts? What's the purpose and what's the idea of getting everybody back on when you're doing the rolling blackout system?
Rolling blackouts occur when there's a lack of generation. So if you imagine there's 100 megawatts of power need and there's only 50 megawatts of generators available, if you try to put that together, you're going to shut the generator altogether. So what they do is they put a portion of the power on so the generators can keep running. So they kind of alternate, an hour or two on, an hour or two off, kind of rolling. So that way that's how that works.
So that must be why a lot of people would have periods where they were maybe on for 3 or 4 hours and they were off for 3 or 4 hours, then back on for 3 or 4 hours at a time, right?
That's right. And that's how that works. And that's to keep from total failure of the whole system. They just keep the generation running that they have available. They keep it running and only serve the amount of load they can serve.
That's a really interesting concept because, you don't think about using blackouts. You don't think about using power outages as a way to solve the problem, but sometimes that's useful in that way because, we're always thinking about getting the power back on and getting on as quickly as possible. But in their situation, some areas had to, experience those rolling blackouts in order to get everybody back on at the same time eventually.
And also, Blue Ridge also has a plan for load curtailment in a situation where there was a generation deficiency in the state and there was a need. So we have like in 5% increments, if we did have to do that, we have a plan ready to go if needed.
When we talk about the weather they had in Texas, I mean, the temperatures we were seeing in Texas, I can't be quoted on this, but I know there were some single digits and below zero temperatures during that. And obviously for areas that are probably more used to 70s and 80s, even in the winter. Can you kind of explain just how much of a shock that is on the electric system and really what the demand is like? I mean, I don't think people understand sometimes the connection between the weather and demand, but really what that does in driving up the demand and making everything else work harder in those situations, especially if they weren't equipped to deal with that.
Yeah. Well, that's an interesting question because, electric load is proportional to temperature. So, the colder it is, the more load you have. But what happens at extreme levels is you end up more of an exponential type. So you actually increase load much faster than the temperature as it drops just degree by degree. I think mainly because people's heat strips come on their heat pumps, and they're running all the time. So there's no diversity on coming on and off. They're running all the time. And then on top of that, people are plugging in space heaters and other things that add to the load.
I think it's something we talked about in the last podcast episode where we talked about energy efficiency and putting the connection together with, a lot of times if it's 30 degrees outside, it's a lot harder to keep your house at 65 or 70 degrees than it is if it's 55 degrees outside. So, I mean, just having that sheer amount of demand, really, you could see that impact happening in Texas at a local level and how that expanded even into their statewide utilities and generation and transmission. But I was going to segue that now. And, we've already talked about whether or not it could happen here. But so how do you, as an engineer, when you're thinking of these things and you see this stuff going on in Texas, what do you think about as an engineer when you're designing the power grid and the structure here and building it? What do we do to prevent things like that from happening or maybe make our grid more resilient here locally?
Well, the one thing we can't control is the power supply from the generator, since we do not do the generation. So we do work with our generators, our power suppliers, and make sure they have enough excess capacity for situations like this. But within the Blue Ridge system, we have to design substations, transmission lines, power lines. We have to design those for extreme conditions. We definitely look at worst case scenarios. We look at situations to where we have heavy load and we lose a certain line. Can the other lines pick up the load? So we look at contingency analysis as well as just a regular operating condition, even under extreme conditions.
So, Mike, I know locally we're doing some big transmission projects up in the mountains. People may have been see us building those lines and pulling that across Watauga County and Ashe County over the last year or two. What's been going on up there? What are you guys doing? I know you've been a busy man the last several months and years, so tell us what the project's like up there.
Okay. This is a good segue into what we've been talking about in Texas. This is a transmission line that we've been working on. This is a transmission line from Ashe County into Watauga County to help feed the Boone area. So we are actually building a transmission line, total length about 17 miles of 230 kV or 230,000 volt transmission lines and a substation in the Rutherwood community. The total cost of the project is about $40 million. And that's a lot of money. But when you think about preparing for these extreme weather events like we have to plan for, this is something right here on our system that we've seen as an area where it would be a weak link, and we're building that right now. We began in 2000, and we actually began planning back in about 2000. The project actually started in 2017. And it should be complete by the end of the year in 2023. And it will add capacity to help serve mainly the Watauga area, but also provide backup power, like we had talked about, for the other mountain districts.
Something that I'm definitely not envious of for engineers or even our line technicians or anybody on the operations side of things at Blue Ridge is the terrain, the ruggedness, just how crazy it is, our area. The fact, you go from Caldwell County just to Watauga, you might have an elevation climb of up to 3, 4, or even 5,000 feet in some cases. Mm-hmm. How do you plan for those sort of things? What kind of planning and logistics and I guess mapping has to go into that? There has to be crazy coordination that goes on just to figure that out and figure out where you're going to put the line. So how do you make those decisions?
We do get some assistance from surveyors and from consulting engineers on some of these really difficult locations, and they actually they use LiDAR. That's a kind of surveying they can do from an airplane and actually survey out the land for us. And so they have programs that actually optimize location of poles and actually help design the line the most efficient way and economic way that can be designed.
So technology really does help us out in a lot of different ways. So I'm guessing when you're explaining that, there's somebody flying over and it's mapping the earth under it, and it tells you, okay, well, I mean, the slope there would be best for a pole there, but the mountainside next to it, maybe not. So that kind of understanding how that works.
That's right. That's exactly right. And that takes pictures, and gets I don't know what it is. It's like 1 million points per 100 feet or something like that. It takes a lot of points to get elevations of the land, the vegetation, any other things, rivers, houses. It catches all that in the aerial.
And we talked specifically about Blue Ridge and our plans to, upgrade certain transmission areas and upgrade certain lines. But do you think in general, a lot of work remains to be done around the entire utility sector of the United States? I mean, I know you hear a lot about infrastructure being dated and things like that. Do you find that's common in the electric industry? Or do you think that's something that's really being worked on right now to get ahead of that?
I think that's a big push, and you've probably heard somewhere people talk about grid hardening, and that's kind of what that is. We have everyone has locations on their system. It's not along the main roads. You're talking about way back in the woods, lines that have been there for years and years, and there's lines in the utility grid that are over 100 years old. I mean, we've gotten that far. And the Blue Ridge system, large percentage of our system was constructed in the 40s, 50s, and 60s. So we actually have lines that have been out there 50, 60, and 70 years old. And so now we're actually in a grid hardening mode to where we're putting focus to go ahead and start replacing some of that old infrastructure. And
when we talk about replacing some of that infrastructure, I know technology grows, and obviously there's been a big gap technologically in life in general from the 50s and 60s to now. So when you say you're replacing lines and you're replacing transmission, what exactly is the technology, or I guess the materials that we're replacing? Because there is a difference in the materials and the lines that were made back then, obviously, and now. But for someone who may look up at, the power lines today and think, I don't see a difference, what's inside those power lines? What's the difference overall?
The lines back then were mainly constructed out of copper. And today we use more aluminum wire. That's our standard right now. It has a steel core for strength, but actually uses aluminum to transport the electricity. So that's one big difference. The poles that were installed back then were much smaller and not as capable of weathering storms. Today we're putting larger poles in, whether it be taller or larger diameter, to actually withstand more of these conditions. And we still, even with the old stuff, we're actually still doing a maintenance program. We're out there treating poles and repairing woodpecker damage and wood rot. We're taking care of those things. So we're on a constant maintenance, even if they are old ones, to keep them in service. One thing that we are doing as well in this construction work plan that we're doing right now is actually focusing on the eastern escarpment. That's an area of our system that seems to get hit more often with ice. So we're actually putting an effort to to replace the old conductor and old poles in those areas.
That's awesome, Mike. And Mike, I really want to say we appreciate you coming on the podcast today and taking time to talk about a little bit of everything. I think we covered a little bit of Texas and the energy grid as a whole in the United States, and specifically what's happening in some of the backyards for these people who are listening to this podcast on our Blue Ridge system. So Mike, thank you for joining us, and we'll be back next month with another episode of Unplugged. Thank you for listening. You can always hit the subscribe button. We're on pretty much any podcasting app at this point. So if you'll just hit the subscribe button, we'll be right there. And that way the episodes come straight to your mobile device or iPad, whatever you're using, and you don't have to look for the episodes anymore. So stay tuned for next month. And until next time, I'm your host, Jacob Puckett.